Hi everyone, thanks for joining us today for our webinar using Docker multi-stage builds to create advanced pipelines. Just a couple announcements before we kick it off. The webinar today is being recorded, so everyone should receive the full recording in an email over the next couple of days. We will have time at the end of the session for questions, so if you have any now or any time during the webinar, you can type them into the chat box in the GoToWebinar control panel. And finally, when you leave today, you will be prompted to fill out a short 30-second survey. Please, if you could take the time to provide some honest feedback. We are always looking to make these sessions better, so we appreciate you letting us know what you would be looking for in your next webinar. And with that, I will kick it over to Alexei, who will start the presentation.
Okay. Hello, guys. Hello. The topic of today's presentation is I'm going to talk about Docker multi-stage build and how you can use Docker multi-stage build to create advanced build pipelines. A bit about me. I'm a Chief of Research at Codefresh IO. The Codefresh is continuous integration, continuous delivery service based on Docker. We use Docker, we focus on Docker, we deliver Docker build and deliver Docker containers to different runtime environments. I'm also contribute and lead several open source projects. One of them is Pumbaa. It's chaos testing for Docker. I'm also going to demonstrate how I'm using multi-stage build to build this project. I'm with Docker for 2 years almost, and I'm programming in Go and Node. Work a lot with Amazon Cloud. Usually post blogs on Codefresh blog site, but also repost them on Medium. So if you would like to follow me on Medium, on Twitter, where I post a different post about technology related to programming, to Docker, to cloud. So please do. So this presentation it's not a basic presentation, so I assume that you guys are familiar with Docker concept and architecture. So let's start just a small recap. Talk about Docker build, how Docker build had been changed. So far, the Docker build actually allows you to create a Docker image using Dockerfile. Dockerfile is an imperative DSL that actually describes build commands, and each build command generates exactly one image layer. So once you run the Docker build with a Dockerfile or pass a content of Dockerfile, you actually generate single Docker image that consists from all these layers. Okay. So if I take, for example, some HTML demo application, which is a basic Nginx application with some HTML pages in it. So I have a Docker file for this HTML application. As you can see, it actually created from Nginx image. It performs some apt-get update and add some configuration, copy HTML files, and actually that's all, and expose the port. We can also see the Nginx image itself. It's start from Debian and download and install Nginx and additional required packages. Create some symlinks and defines the main command to execute Nginx. And this is how the image layers looks like. So as you can see, for each command is actually a layer with size is created. So you can see that currently, since I'm looking only on 2 files, I could also add the addition of the Debian itself, but I skipped this. So, for example, the bottom line at the bottom, you can see the HTML demo Docker file and images it creates. Okay. So, for example, update, create a new image with 11, almost 12 megabyte size. And if you look, for example, at Nginx image, you can see that installing Nginx takes about 20 megabytes, 19 megabytes. Okay. So each command creates exactly one layer, and once you build your Docker file, you have single image. So far, this is what we had before Docker 17.05, which was released about 2 weeks ago. So let's take a look at what problems we had with Docker build approach. Okay, what we wanted image we want to have, when we create a new image, we want to have some basic runtime, some configuration, and actually application itself in form of application binary or bytecode or whatever it is. Okay, it depends on application. Maybe even source files if it's a script application. But actually what we have, usually when we build the image, we have compilers and debuggers and different additional tools like test frameworks and profiles and code and different build artifacts if we don't clean up stuff. And then we have runtime configuration application. We have a much bigger image with a lot of packages installed, which actually are not required to run your application. And usually this image several times bigger, from 4 to 10, even more times bigger than the image you actually need to run your application. Not the ideal situation. So people come with different approaches. For example, Docker builder pattern. It's one of the popular approaches when you have 2 Docker files. The first one, actually Docker file that for your build environment that contains all build tools and testing tools and linters and debuggers. And using this build Docker file, you create build container, and this build container, once you mount your code repository into it, or you add your code into this build container, you can create different build artifacts. This can be Java var files, it can be your compiled application or packaged application. And second one is the Docker file for your runtime. It contains bare minimum of what is required to run your application, and it takes the build artifacts that were produced by a build container. So this pattern works pretty good. What is actually, it has some drawbacks, like you need at least 2 Docker files, sometimes even more, if you would like to have a separate container for testing and maybe load testing and for security scanning and for validation. So you start to create multiple, encapsulate your different environment, not only build environment, but also test environment and validate environment into Docker images. And once you have multiple containers, you need to orchestrate this build flow. So you start to use different shell scripts, or make files, or CI pipeline tools with help of YAML or XML, which allows you to define multiple steps and pass artifacts between steps. And actually, you need to learn additional tools, to introduce these additional tools. And if this tool is also, for example, available, it's not always easy to reproduce this flow on local machine. So sometimes you end with the situation when you have build working on CI on some dedicated machine, but it's not easy to reproduce on local machine. So Docker with 17.05, they introduce the concept of multi-stage build. which allow you to build smaller images and separate the build into stages. For example, in the first stage, you create full build environment, the big container, and the second stage, you create minimal required runtime environment using single Docker file and running single Docker build command. Okay, the benefits, as you see, it's single Docker file. It's one syntax to learn. You actually already, if you already practice and use Docker, you already know the Docker file syntax. It's the same build, single command to execute. It works on local machine and it works on CI servers, and actually it will work on any machine if you create it properly. And you also can create multiple stages, not only 2 stages. You can have single Docker file that define different stages, like define a base runtime image and stage for compilers and linters and testing. And then the final stage is actually image that you're going to release, tag and release, okay? So if we'll take a look how actually it's done by extending a Docker file syntax a bit. So on the left side, you see the small Docker file. That what is unusual that you can see there is multiple from commands. And these multiple from commands, each one of them actually define a new image, and only last from command is actually the final image created or tagged from the last from command. Okay. So you start from base image. You define, for example, Alpine as a base image, and you install the CURL there. And then you have a different image, the second image, just print out, create a hello file, and third image from Ubuntu, it's create a Word file. And in the file image, you can see the copy command. Copy command has been extended to allow you copy not only from the Docker host machine, but also from these intermediate images. So you can specify the image you would like to copy files from. For example, copy from second or copy from third, and copy hello from second image and Word from the third image. And actually, this, as you can see, it's just the final image, it derives from the base image, and then it copy different artifacts from intermediate image. And during the build process, all these layers are created, but only the layers of the final image have been tagged with tag you specify with Docker build command. Another bit of extension, as you can see, so after from, you can specify keyword as and provide the name, which you can reference later on when you derive from intermediate image or when you copy files from intermediate image. But it's optional. You can also use indexes, which, in my opinion, makes file less readable and more fragile. Okay, so I prefer to specify to provide this optional name. Okay, let's move. So we will move to some real example. It's start with Node.js. Multi-stage build. I take demo chat. We use the Let's Chat application. It's kind of similar Slack for small teams that allows you to manage chat, create rooms, and search messages, attachments, etc. So it's implemented in Node.js. And I'm going to run in meanwhile, so you can see that it is working. So you can see when my Vim complains, it doesn't know the Docker file format, so it complains on invalid command. But actually, you can see I have a base Alpine image which install Node.js and Yarn. I'm using Yarn as a package manager. Then a dependencies image which derives from base and add additional build tools like GNU C++, Python, Make, and Kerberos development packages. These are required for native Node modules. This should be compiled. Then actually install all modules for production and copy them inside. And then install all modules, including testing modules. The test takes dependencies as a base, execute a linter with ESLinter, then scan code for security violation, and then execute a unit test with Mocha test. After, if everything passed, so I have the last image is actually is going to be released, which is base, derived from base. It copied dependencies only from production modules from dependencies intermediate image, and actually run the application. So I'm going to run the build. Meanwhile, actually, you saw it was pretty fast since I already built the application. I can, and all of the layers are cached, so I would like to show how actually I'm going to build it when it's not cached. I'm going to remove some images. So it's demo chart, and it's intermediate image. Once again, I'm going to run. Oh, sorry. Okay, I'm going to run the build. So right now, all commands start to run. I'm starting from base image, adding nodes, etc. Meanwhile, it's run. I'm switching back to the presentation. So as you see, actually, I create two images. Actually, I have more intermediate images, but since they derive from the same base image, all layers are stacked into one builder image. Okay, so the builder image contains Node.js itself, runtime for Node.js, application modules, Yarn as a package manager, Mocha as a testing, ESLint for code linting, for static code analysis, Newman for REST API testing, Gulp for task automation, NSP security scanner for code vulnerabilities, for known vulnerabilities in NPM packages, Istanbul for code coverage, and I also need Python and GCC and G++ and C++ and Kerberos development and some additional modules just to compile Node native modules. Okay, and the total image size is about 568 megabyte, where the final image I'm going to deploy, it's only 112 megabytes and includes only Node.js runtime, application models I copy from dependencies, and Yarn as a package manager, which is actually quite optional. I can also remove it and make image even smaller. So we can you can see the link here. After the webinar, we will share the slides, so you can go to the link. It's in a separate branch. It's called multi-stage branch. You can fork it and play with it and try to compile it. As I said, you need the latest Docker version. So I'm going to. Okay. The build continues. As you see during the build, it creates actually kind of flat all these commands as a single commands, and for each command it creates a new layer and stack this layer on top of each other. Okay, it will, I believe for this project it takes about 5 minutes to compile first time, but after it finished the compilation, next time Docker build will be much faster till you modify the package.json or some other files. Since all these layers, they actually are cached in a local repository. So if a layer had not been invalidated, if you, for example, you modify only application code, so the build will be pretty fast. But since I've cleaned everything, it takes right now it takes some time to build. Meanwhile, I'll go to another application. So, for example, the next one is a Go application. It's a Pumbaa. It's open project actually created. It's a chaos testing and network emulation for Docker containers. I maintain it, and in order to build this project, you need actually Go 1.8 compiler and additional tools. You need Glide as a package manager and Cover for test coverage, Test for as a testing framework, and GitHub release to release. Actually, I released the project while I compile it. I also created the multiple version of this project. I forget to put here GOX. It's cross-compile for multiple platform. And I also use the GitHub release as a tool to release to the GitHub, where I create push multiple binaries and create GitHub release with release notes, etc. Govros for integration with Govros coverage service, and Bets for integration testing, Bash integration testing, and additional tools like CURL, OpenSSL, Docker CLI, again used in integration testing since Pumbaa itself works with Docker. So, and the whole builder image that contains everything I need, it's about 487 megabyte, while the runtime image, which actually based on Alpine, but it can be also a Scratch image. So it's about 15 megabytes and can be reduced to 12 or even 10 if I use the Scratch. It contains only the compiled binary. It's pretty small. So let's switch, and I'll run also the. Okay. Meanwhile, you can see that application. The Node application compiled. While I was running the application, I also executed For example, you can see here ESLint. I execute lint2 to find static code analysis error violations. So no one is found. Also execute security scan. I decided not to fail build right now, but there's some security violation that should fail build. If I would like to address and fix them, I need to update them. These packages, you can see I found 8 violations here, and also executed multiple tests and calculated the test coverage. Okay, so you can see it says 16 tests executed, everything passed, and also executed the test coverage. Calculated the test coverage, and once everything passed, I actually created the image. So if I'll take a look now at the images, you see the local demo chart image. It's 112 megabyte, and there is additional image also created 2 minutes ago that contains all layers for build containers. These intermediate images combined into single one. It doesn't have any tag, so it's not tagged. If you will run some cleanup commands or Docker system prune commands, you can delete it. So maybe it's worth to tag this image also manually. Currently, Docker doesn't support to do it automatically. So it's a 568 megabytes, and if I enter into this image, I'll see all packages, all tools I needed to actually compile and run my application. So switching to Pumbaa, I can do the same. Just a moment, I'll just want to delete the images I've created. The Go project will be faster. So I delete the images for Pumbaa. It's the final binary and intermediate builder image. So right now I'm going to run it. I need some additional build arguments I use, and I'm going to run it. The Docker image itself takes about a minute and a half or 2 minutes to run. So currently it's compiles the Docker install bots and compile the application and bring install Docker client and some additional stuff. So let's maybe take a look at the code for this Docker file. So for multi-stage build, you can see I have 2 images. One is builder image. So it's derived from Go builder on build image. It's a basic my modification of default Go on build image. Then it adds bots. It's a unit integration testing framework for command line applications. Also install Docker client. Execute compilation. Go build is actually execute compilation, and then run test and create coverage report for these tests. And execute integration tests using bots. Okay. If everything passes, I go to create a runtime image, the final image, actually derived from Alpine. And as you can see, just define user group, install Gosu. Gosu is like sudo, but for running project not as a root user. And copy from the builder image, it copies the Pumbaa binary and some helper shell script. That's all. So switching back to the terminal. No, here. So right now it's going to compile the application, fetch the vendor dependency packages, run tests, and calculate the coverage. So you can see all tests currently being run, and all of them passed with 68, 86, and 62% coverage. Also run integration tests. And right now it starts to create the final image, fetching Alpine, and it should be pretty fast, I believe. And then we could see the final result. Okay, another 5 seconds. Okay, we copy from builder, we copy the Pumbaa image, and then we copy the entry point. And we can see two images created. So one for without tag, it's the one that contains the Go compiler and different tools I need for testing, coverage calculation, and deployment of my application to GitHub. And the runtime image itself, it's only 15 megabytes. So it was a single Docker file, single build command that produced these two images. Let's switch back. Okay, so in this case, it's, the final image is 30 times smaller than the image with all tools. You can currently with Codefresh, we start to support multi-stage build, so you can actually, it's as far as I know, it's the only continuous integration service that, or CI/CD service that allows you to play with Docker multi-stage build today online, meaning you can connect your public GitHub or Bitbucket repository. If you have, if you create the Docker file with this new multi-stage syntax, you will be able to build it easily with Codefresh and get, based on commit or pull request, for each commit or pull request you will create a new image, and this final image will be pushed to your Docker Hub or different other repository. If you would like to play with private repository, we have a free trial for, so you are welcome to subscribe and play with it. Another use case, it's a multi-build use case, okay? It's actually that the idea here is that using single Docker file with this multi-stage feature, you actually, as you saw, you create multiple layers. Some of them are stacked on top of each other, so you have kind of single image, but you can create multiple image also. And actually, it's possible right now to build multiple services, multiple Docker images from single Docker file. What's not possible to tag all these images. You actually can tag only the last one using Docker build command. The workaround would be, to add some kind of mark. I'm using label as the last statement, as the last comment into image you would like to tag, and then using Docker history command to search for this label, this grep, and tag this image. So when this can be useful, then it can be useful to create multiple Docker images from single Docker file. For example, there are multi-project builds in Java world. They are quite popular in Java or Scala world when you have a single Maven file or SBT file that produce multiple artifacts while you're running it. So you produce multiple WAR files or jar files, and you may still want to, while you still have this single build that creates multiple dependent services, interdependent services, you might still want to deploy them separately for the sake of scalability. For example, different services require different number of instances to be run on your environment, or they might need different resources available for these services. So you produce multiple Docker images. Another case when you might need multiple Docker image, for example, if you create a multi-platform application using Go, you can compile the same code into multiple architecture, multiple platform. It can be Windows, Unix, Linux for 64-bit, for ARM, etc. So you can use the same code, the same version, you compile the same binary, you have multiple binaries. Right now, I would like to put them into to create multiple Docker container and then combine them into something called multi-architecture Docker image. Okay, so when you pull this image, it will be pulled based on your Docker client architecture. Okay, so far I believe I've covered what I wanted to cover. So guys, if you have questions, I can try to answer. Okay, Brittany?
Yes, so if anyone has any questions, we'll give you a second to type any in the chat box in the GoToWebinar control panel. Give everyone a couple of minutes to ask some questions, and then if not, we'll move on and share our contact info, so if people have questions, they can reach out later.
What I want to add, I've also wrote a blog post about this topic with a more detailed example of Node.js application. Mm-hmm. So it's on our blog website, so you are welcome to visit and read it. And
someone did ask if you had a sample of the last use case.
I'm working on it. I would like to create a multi-architecture Docker image for Go application. Actually, take my project. I'm compiling it today for multiple platforms, but I create Docker image only for Linux. So I would like to create also Docker image for Windows architecture, maybe also for ARM. I'm not sure if it's useful for ARM, but just to play with it.
Great. Okay.
Once it will be ready, I'll publish it on my blog or Twitter. Yes, it will be on GitHub once I'll.
Okay. And these are some additional resources. You know, if you guys want to check out some of Alexei's blogs, you can check them out on the Codefresh site. And you know, you can also check out our meetup page for upcoming events and webinars. And let's see, let's get to the next question. Oh, and he asked if the same person asked if that example will be on your GitHub when you do create it, I guess.
Yeah,
Okay.
I'll post it there.
Okay,
and guys,
great.
I invite you to try Codefresh, try even for this specific use case, playing with multi-stage build. It's working today.
Exactly.
And
Yes.
Docker Hub, they promise to support multi-stage build till the end of June, so you may wait and try it on Docker Hub itself. It will be there at the end of June, and today it's on Codefresh.
Perfect. Yeah, everyone can, you know, sign up for a free account and play around with what you saw today. And if you guys have any questions, you can always reach out to us on the website in the chat box or at Codefresh or at contact@codefresh.io. That's an email for anyone to reach out with any additional questions after the webinar. And like I mentioned before, we'll be sending out the recording over the next couple of days. So you know, you can reply to that email as well if you think of anything after this and that you want to ask Alexei. I'll make sure to forward that along. So, great. Thank you guys for coming, and thanks, Alexei, for the talk, and we hope to see you at our next session.
Okay. Thank you, Brittany. Thank you, guys. It was nice to talk with you.
All right. Have a good one. Bye.